Hi everyone. It's great to be back at Carleton. I'm just as astonished that I'm here as I'm sure many of you are. It's been a while. I do have to say, so I started at Carleton and did a BA here, and did Oxford and the LSE, but a lot of the papers and the primary research that I'm doing right now are still all derived from textbooks I bought for Hans Martin's class and William's class. So I think my intellectual trajectory was formed primarily at Carleton, and even though you hear Oxford and LSE sometimes in the news, I think the quality of the professors in the political science department at Carleton is just incredible. So for you being students here, you're all very lucky. I don't know if there's a better political science department I've come across. So now that I'm back, very excited to be here, very happy. I'm here to talk about something that is maybe not quite as enjoyable, which is this connection between climate change and nuclear weapons that we're hearing a lot in the news right now. So to open it up, I will start with one particular quote from 1972. This is Richard Falk, and he says, "There's little evidence that any change in the structure of world order is likely to come about in the years ahead, unless it is provoked by a catastrophe of awesome proportion. But let us not be deceived. The first need is to awaken the consciousness of men and women everywhere to the causes of their distress." And that was from Falk's giant phone book sized book in 1972, where he went over pretty much every single environmental problem known to international relations at that point in time. Now, a good question to ask is whether or not climate change is even included in that book. We'll get to that. Moving along, talk generally is framed around the concept of global climate change. So what is global climate change? We're usually familiar with the topic. The climate is a big global thing. It's working very well until all of a sudden we threw a whole bunch of CO2 into the atmosphere, and now it's starting to warm. And so we're bombarded with issues of global warming, the planet's starting to melt, tremendous media coverage, CO2, fossil fuel emissions, the classic polar bear imagery that we see, and even magazines that never used to delve into global environmental politics or issues like climate, such as Mrs., as we know, a great bastion of environmental thought through the years, is now also rising up to stop global warming. So where does this concept of global warming that we all know and we all hear so much, it's actually Mike Hume that describes it now as a new background context for a kind of everyday reality. Everything we think today, we think in terms of climate change. If it's going to take out our recycling, if it's what we eat for lunch, if it's how we're going to get to a conference or a talk, it's always framed in this background of climate change. So where do we actually get it? Well, the typical thought is that it's a mix of science and politics, right? So on the back you have NASA, this very complex scientific calculations and energy maps. You have the classic Keeling curve, if anyone knows what the Keeling curve is. It's where they started measuring the concentration of CO2 in the atmosphere back in the 50s. You can see it going up and down throughout the years. It's called the hockey stick graph. And all of this gets funneled into what's known as the Intergovernmental Panel on Climate Change, and this was formed in 1988. And so whenever we hear about climate change in the news today, you always hear the IPCC after it, because it's kind of the international gold standard, where every single state contributes to the IPCC, and they come up with kind of the golden version of what global climate change is, how we're going to adapt to it, how we're going to mitigate it, how we're going to deal with it. And finally, there's also an assumed linear development, the traditional history that goes along with this. So in a lot of IR textbooks right now, you see climate change is this big global problem, we've known about it for a while, and you see this smooth historical development from its discovery to the issues that we have today. So you have Fourier in 1824, he discovered that incoming light from the sun actually gets trapped in certain ways by the Earth. You have Tyndall, who also argued in support of this. The big name here is Svante Arrhenius. In 1896, he was the first person, apparently, to conclusively write, yes, fossil fuel emissions will collect in the atmosphere. They will trap the rays of the sun like a greenhouse, and it's going to get the Earth warmer and warmer and warmer. Chamberlain, Callendar, I won't go through all of these. You can ask questions afterwards if you want. But the general logic is we learned more and more. There was a steady increase of knowledge up to today, and now we know climate change is this big global problem. So when I was a PhD student, and of course, like all PhD students, you ask, well, what can I write a PhD thesis on? I looked at this and I thought, aha, there's got to be some flaws in this, right? I have all this training in Foucauldian genealogy coming from Carleton. So I think I'm going to apply this to climate change, and I'm going to come up with some big earth-shattering thesis. It's going to be amazing. And like all PhDs, I immediately realized as I went forward with this idea that it had been done probably 200 or 300 times. The history is really messed up. And it had been published, and if anyone wants just a fascinating exploration into the history of climate change, I'd recommend J.R. Fleming's Historical Perspectives on Climate Change. It pretty much goes through how every single one of those narratives I just talked about does not hold. Super interesting book to read, but not so interesting when you're a PhD student and you realize you feel like you're floating dead in the water because all your best ideas are gone. So in general, what Fleming argued and what he conclusively demonstrated is that all those historical nodes that we take on this path of the linear discovery and development of climate change didn't really exist like that. Fourier wasn't actually talking about Earth, he was talking about other planets. He only mentioned Earth like sporadically in his like homemade notes that people collected afterwards. Svante Arrhenius, he mentioned fossil fuels and global warming, but it wasn't really his focus. He thought it would be a good thing. He wrote about it on the side, and you get his 1906 book called Worlds in the Making, and he dedicates 2 pages to the hothouse theory of CO2 and global warming, and he actually thinks it's going to be a good thing. In fact, Chamberlain and all the rest of the kind of scientists that started developing this, they completely gave up on the theory. They say, we can't believe we fell for Arrhenius's crazy claim. This doesn't make sense. And from pretty much 1910 until after World War II, the dominant theories of climatic change were from glaciology. They're trying to figure out how ice fields worked. One weird thing I will mention before I go on is that instead of this idea of global climate, you actually have sovereign climates and regional climates. And it turns out they were always anthropogenic. So a great example, let's see if I actually have it on here. The screen is really small in this view, so I can't actually access it, that's okay. So say the founding of America, the American forefathers, right? You have James Madison, you have Thomas Jefferson, you have Benjamin Franklin. They're actually the first ones to take meteorological measurements in the United States of America. And why were they doing that? They were convinced that they could cause local and regional anthropogenic climate change by cutting down all the forests, burning them, warming the local climate, and that would make kind of the American frontier more hospitable for white European civilization. Because back in the day, it was all about the North American climate was rough, it was inhospitable to civilization, so if we go in there, we change the climate that suits the needs of pretty much white males, we'll be able to move in, we'll have schools, and we'll civilize kind of the wild frontier. So it was always, anthropogenic climate change was always there. You always had people thinking that they could make actions to change the regional climates, from people blaming witchcraft on cold climates to American forefathers. And as I mentioned, it was based on ice. CO2 very rarely figures into the way that people thought the climates actually changed until well after World War II. And there is a reason for that. There's no climate science until well into the 1950s. And this is, I won't go into it because I barely know what it is. This is a primitive weather forecasting equation. And back in the day, before computers, in the early 1900s, you had Wilhelm, I can't speak Norwegian, I would pronounce it as Bjerknes, and this British guy named Richardson. And they thought, okay, we can actually calculate the weather by coming up with these very complex theoretical explanations of what fluid dynamics are and how the atmosphere functions. But the catch was, in order to calculate the weather in this way, it would actually take, I think it took Richardson 6 weeks of constant calculating, working 12 hours a day to work out 6 hours of how the atmosphere functioned over one small region. And then that failed terribly. So the math to actually calculate how the climate actually works was far beyond the scope of the human condition. People just gave it up. So there was literally no climate science as we know it today from pretty much 1910 until the 1950s. So that made me realize, reading through all this, the question isn't when did our global climate start to change? It was actually when were all of these sovereign, independent climates going global? So that was a completely different research question. It was inverting it. So I started chasing that up a bit. Yeah, how and when did climate change become global? The way I dove into it was, well, what else is global today? Maybe I can connect it to something and kind of find an intertext. course, what do we hear all over the news today, right? We hear nuclear weapons, there's going to be stuff going on with Kim Jong-un and North Korea, and we hear about climate change. And of course, there's Trump, but that goes without saying. But you can trace this back through the records, through Pew Research polls, through both public and both through academic and also security experts, and you always find climate change and nuclear war are up towards the top. So I decided, okay, what's a good resource to see how these things interconnect and overlap throughout the years? And then I started, you look through research as you do, and you find particular publications you can gravitate to. And I won't go into a whole bunch of Foucauldian terminology, but I decided to use as my archive or a particular source to go back to trace this relationship, the Bulletin of the Atomic Scientists. It was founded in 1945, and its apparent mission were physicists and scientists that worked on the Manhattan Project yet could not remain aloof of the consequences of their work. And what made it very strange is despite this magazine being entirely dedicated to atomic war and nuclear weaponry, in 2010 they actually added climate change to their list of global threats. So again, there was this strange crossover of these two global threats that seemed somewhat interesting, and you follow these leads. So you can see at the most recent update, January 26, 2017, over the course of 2016, the global security landscape darkened as the international community failed to come effectively to grips with humanity's most pressing existential threats, nuclear weapons, and climate change. So you seem to have these two global threats constituted beside one another, yet apparently very different. Climate change was just added in 2010. So I thought, okay, I'm going to dig back in the Bulletin to see how and when the climate starts entering into this, how it's used, who uses it, when, what circumstances does it develop in, and also to check out media sources, other things going on. So just for our own kind of records, this is the very first ever Bulletin of Atomic Scientists in December 1945. You can read the quotes if you want, but basically it says it's going to save humanity from itself. One thing, if you go back, and I don't know if the Carleton Library has it, this was the very first bulletin, and you realize how much of it echoes discourses and expressions that we hear today, not necessarily to do with nuclear war, but with climate change. So you start reading it, and it's like, I've heard this stuff before, but now it's about something else. So again, there's that constant interplay in the background of, it's almost like I've heard this before, there's an echo that's going on here. Prior to starting the bulletin, there's a book that came out called One World or None. And this was like the precursor to the Bulletin. And these were the majority of scientists that actually worked on the Manhattan Project, that worked on the bomb, and again, could not remain aloof to the consequences of their work. So they produced this little nice booklet. All of them writing it. There was Oppenheimer, there was Einstein, there was Niels Bohr, there were some of the top political philosophers from back in the day. And it mirrors almost exactly things that we hear today about climate change and the Anthropocene epoch. Everyone's writing about this is an existential crisis. This is humanity is taking control of the planet. Humanity, it's its first time we're going to annihilate ourselves. This is transnational. It moves and flows above and beyond the state. We need to unify people behind this tremendous threat. We're running out of time. Their difference is, okay, we're going to take the world state as a solution. We're going to have some kind of supranational government to give our power to. It almost echoes very much, I don't know if anyone's read Planetary Politics or Planet Politics in Millennium. If not, I have to give a shameless shout out to volume 44 because we had to publish that. But they're very similar. So there's not too much somehow that's changed in the span of almost 70 years. There is one different voice in the book though, and that's Walter Lippmann. He's getting up there in the years at this point in time, but he actually writes, no one ever gave him any credit for it, Sole one state thing's never going to work. All right, you look at the way collective security functioned. Collective security didn't work because to save everyone from themselves, they had to be willing to risk ultimate war in order to save everyone from ultimate war. It just doesn't make sense. So he says the world state, forget it. If you guys really want to prevent atomic disaster, what you have to do is get into everyone's head. And I can't read the quotes on this because it's not coming up on the screen, but he basically describes how you need to come up with an idea that's so powerful and so uniform that it guides people in their conduct, that it actually structures their consciousness in ways without them even knowing it. So it's this bottom-up structure of saving people from themselves. And then the next chapter after that is Einstein. So that kind of trumped Lippmann, and everyone just forgot about him. Everyone's waiting for the world state. So this was where I was kind of starting out, diving into this research. Sounds a lot like things we're used to today. And then you have Lippmann saying, almost echoing Foucault in his lectures in the 1970s, no, you have to get into everyone's head. You have to have them work from the bottom up to channel their conduct. So tracing through the Bulletin in the 1940s, looking for these mentions of climate change, of CO2, of greenhouse warming, you don't find too much. You see a lot of funny ads and expressions that we don't really see anymore. You have climate only used as a climate of opinion, a mental condition. Right? You have actually Hans J. Morgenthau, he's in there a bunch of times writing about this because he was all about getting into people's heads. You have lots of discussions about the anthropogenic destruction of the planet, but there's no references to any of climate change, CO2, greenhouse effect, despite the underlying tone sounding very much like what we're familiar with today. Their call to a new planet politics was still push for a world gov. I didn't put it on this, but you can actually Google Bulletin of Atomic Scientists, and you have, I forget what issue it is, I'll be happy to email it to anyone if you're interested, but they came up with their own world constitution. So like, we're gonna make this government happen, and they wrote out a full constitution of what to say, what to do, how it's gonna work, which is, it's fun to read. But in the late 1940s, something happens, which is, how did the Americans actually know the Soviets had nukes? Right? No one told them. Americans had a big issue where the Soviets were really good at spying. They knew all about the Manhattan Project, how the bomb functioned. Obviously, they took a bunch of that back and they built their own. But the Americans had really poor espionage. They couldn't get anyone in to Russia, and those that did soon were discovered and were shot. So they were thinking, damn, how do we actually find if Joe has the bomb? What do we do? And they started looking up. So they, well, what about the weather? Can we do anything to detect this? And so they started investing heavily in radiological research and radiological detection mechanisms. And so to make a long story short, they had Roger Revelle, who is known as one of the founders of climate change. He started out back in the day working for the Navy on something called Operation or Project Rain Barrel. This had to do with detecting the level of radioactivity from rainwater that was collecting in the sky and raining down. So the Americans eventually detected a spike. They sent this to the British. The British sampled air over Scotland. The Americans did it over Alaska. They noticed a massive spike in radioactivity, and that was in September 1949. So they knew, okay, in August, you know, Joe detonated a bomb. It's the only answer to this, and he had. And that was known as Joe 1. So the discovery of the Soviet nuclear capacity through this radiological testing actually gave them some great ideas. They're like, wow, maybe we should pay more attention to what's going on up there. Maybe, you know, these parceled regional climates can actually tell us more if we learn how they're integrated. And so what they soon discovered after this, these radionuclides, or these pieces of radioactive debris that are in the, to do something and they have to go somewhere. And this is what we know today as fallout. Now, for people that were studying weather, people working in the military, people were wondering what's going to happen to this atomic debris and these atomic bombs that we detonate. Where do they go? What does it do? Who does it reach and how fast? They were always looking for a particular tracer, right? You can't reach up in the sky at different places and just grab different molecules. What the explosion of these nuclear weapons actually allowed the military to do at this point was to trace where these bombs went and how. So you blow up a bomb somewhere, releases a bunch of stuff into the air, you can actually sample where it goes, how it moves, how fast, what currents. So as they started doing this more and more and more, using this radioactive form of carbon, carbon-14, they started realizing, wow, there's a whole bunch of stuff going on up there. It's connected in all these different ways, it has all these different particular patterns and flows, and all of a sudden you actually have the birth of what we know today as a global atmosphere, of global atmospheric circulation. So it actually came into being as an actual concept debated by military planners and scientists alike. They were so imbricated with one another through radioactive weaponry, through the explosion of atomic bombs. That was the first awareness that we had of this global climatic machine that wasn't limited just to these individual regional parcels of states. Problem is, you can't just reach out and trace all over the world where these pieces of radioactive debris are flowing. It's just impossible. The Earth is a big place. The next best thing you can do is calculate them. But you remember that giant spreadsheet of calculations that was just up there? This was really hard to do, right? They gave up trying to calculate atmospheric fluid dynamics before World War I and after because they just couldn't handle it. But what happens after World War II? That happens to boost the possibility of actually realizing what happens with these debris flows and where they go. You have the invention of the computer. This was primarily at Princeton. This is John von Neumann, or Johnny von Neumann. Again, one of those scientists who was very heavily involved in the Manhattan Project and the design of the bomb. But when he was designing the basic foundational structure of the computer, he's also the father, they say father, of game theory and rational choice mechanisms that we know today. Well, he was also designing this computer, and they said, we need you to help us win this new race with the Soviets. What can you test it on? He said, there's no more complicated thing that we can test this computer on than atmospheric fluid dynamics, and essentially weather and climate prediction. So the very first computer as we would know them, the ENIAC, which is the electronic numerical integrator additive calculator, or something like that. ENIAC was dedicated to studying atmospheric patterns and flows to help the Americans try and win this Cold War nuclear race. To test it, we still use this today. Von Neumann designed what we know as a general circulation model. This is a GCM. And this is where our knowledge today of the global climate actually comes from. So we can't see it, taste it, touch it, smell it. Even the IPCC and every state in the world that follows global climate today uses this foundational general circulation model, which essentially divides the whole surface of the planet, oceans, surface, atmosphere, into a series of grids, and calculates within each grid the temperature, exchange of moisture, all that kind of stuff. It basically came from von Neumann and this foundational model that he designed alongside the Americans and the British after World War II. Interestingly enough, in order to spread the knowledge of this general circulation and these complex atmospheric thermodynamics that's now starting to be used more and more at this point in time, a founding text in climate science was actually Ritzmeier's Difference Methods for Initial Value Problems. And this is the textbook that was actually designed for weapons researchers, for people looking into nuclear shock waves, the tremendous explosions that radiate out after a bomb is designed. So you have the foundational climate scientists in the 50s now reading the exact same textbooks as those designing nuclear weapons and trying to trace how those shock waves actually work in the sky. I bought one on A-Books. It didn't arrive today, but you can read the first couple pages online, and you can imagine someone saying, I'm going to go to school to try and study how this global climate works, and the first chapter is all about how to win a nuclear war. So right from the get-go, in terms of how it congealed into being as an object that people could discuss, how it was researched, how it was thought, how the computations worked, you had this kind of nuclear undertone justifying this global climatic object. So from the start, it's almost not like they're different objects per se, but that they're different branches coming from the same tree. But this does take us back to the Bulletin. This is what happens when you start with what archive, it just sends you off in all these random places. But returning back to the Bulletin, still in the 1950s, there's no such thing as global climate change actually mentioned. The focus is now on this radioactive carbon. And the issue is because these computers are still so weak, they can't handle computing the whole globe. So again, those original calculations that took Richardson 6 weeks to do, if you were to do the whole globe, hypothetically, Richardson thought it would take 64,000 people simultaneously calculating. Someone actually looked at Richardson's original equations and said, no, this guy's all wrong. It actually would have taken 204,000 people working simultaneously to calculate the flow of the global climate according to these equations. But now, through the computer, Johnny von Neumann and the way it's all set up, you have very fundamental rudimentary GCMs, climate models, being developed. The problem was they could only do it on a regional scale, and they weren't predictive. So now we're trying to see what's going to happen to the climate in 100 years. At this point in time in the 50s, they didn't really know what they were looking for, and they couldn't even work into the future. They're just trying to get today. If we plug in a series of values and variables, will we actually understand how the climate works? And again, 57, you remember Ravel, right? Operation Rain Barrel. He and Suess now start reviving the CO2 theory of greenhouse warming by saying, oh, it turns out if you look at how much CO2 is absorbed into the ocean, it actually gets spat out. So maybe there is something to be concerned about. Now, this is something, again, mentioned in IR literature today as this big, mind-blowing document we should all pay attention to is this huge node. Again, at the time, no one really paid that much attention to it. It was just another theory in this very developing world of climate science. It's kind of like today, if you think about a lot of the articles that might get passed over. 50 years from now, people looking back might say, that was a key article, that guy really nailed it. But we're all in the midst of things, we can't really pick it out. So they nailed it in this piece, but no one at the time really cared that much. Hans Suess, writing in the Bulletin in 1961, you actually see the first mention of the greenhouse effect in CO2. And again, this is 1961, still relatively recent. He does say may affect the heat balance and the climate of the whole Earth, but he does go on to say at this moment it's really inconclusive. I'm not quite sure. So studying this bomb radiocarbon is key, but now it's not really working anymore because people are detonating so many bombs anywhere. You can't trace it because it's becoming so ubiquitous. And he does mention the greenhouse effect, but there's I don't know why that thing is there. He does mention the greenhouse effect very slightly, but he also does say, and I have the quote, I can't scan it here. It says, you know what, it's still really inconclusive. The science is still out. This is just a theory. There we go. Also in 1961, in the next issue after Suess, you have someone writing, you know, in spite of the huge energies involved in climate, many people think man has already changed the Earth's climate. But then he goes on to say, yeah, since prehistoric times, everything, catastrophes, droughts, hurricanes, frequencies, it's always been blamed on humans. And he says, yeah, actions with the gods. During the Civil War, they blamed it on cannons. During World War I, lately nuclear explosions have been blamed for moving hurricanes. If you scroll down to the very last sentence in the bottom, it's none of these imputed relations can stand up to the objective calculations and statistical texts. So here you have the Bulletin, which again is like the highest level scientists and policymakers converting their work into discourse for the public and to be incorporated into states around the world. And you have what you see in the 60s. They really don't know what the hell's going on. You have this back and forth between people arguing, can we affect the climate, can we not? How do we do it? How does it work? So that narrative of constant development that we read in a lot of these texts, it clearly isn't there. You can even see later on in the 60s. All the way up to 1969, people are writing, how may all these fluctuations of climate be explained? Numerous hypotheses exist, but the search for an answer continues. And even in 1970, the basic causes of these variations in the global climate machine are as yet unknown. Many suggestions have been offered, but we have to learn much more about the machine works before its causes can be reliably evaluated. So essentially, we were landing as a human civilization, if you want to call it that, on the moon before we actually knew how the global climate functioned and how we could trace how it worked. This is just fun. There was an article on the electric car in 1969, because that's all the hype. And I just had to toss it. I have a folder full of random mentions like this and cool graphics. It has nothing to do with, I think it mentions the greenhouse effect, but the electric car was designed to solve the pollution crises that were starting to affect the Earth, as people said, on a local scale at that point in time. But this whole hype about the electric car, I just thought it was kind of interesting to toss in, like, yeah, we were debating it back in the 60s as well. And I love, if you're trying to sell someone an electric car, that's the car you want to go with. You want to take a horse and buggy, pretty much, toss a motor in it. But this takes us to the 1970s. In the 60s, no one knows what the heck is going on. Climate modeling is still developing, but instead of focusing on CO2, there's another kind of entity that enters the mix, and this is particulate matter. So instead of global warming in the 70s, you actually see a new debate pop up, and this was global cooling. So the theory behind this was, instead of CO2 warming the planet by trapping heat, you have the industrialization of so many societies right now where they're kicking so much crap up into the air, it actually blocks the sunlight. The sunlight reflects off of these particles, and so you don't have as much heat reaching the Earth, and you have this global cooling. And this became a bit of a media event. It was in Time magazine, it was in Science and Mechanics. Today, people look at it as just this random thing, climate denialists, as they're called, will say, this is proof that climate modeling doesn't work. It's like, well, no, at this point in time, the science was still developing. They were starting to look at the way these particulates started to interact in their global climate models, and they said, yeah, this is a viable scenario. And the Earth was due at this point in time for another ice age, just the way these natural cycles work. So here we are in the 70s, and instead of this progressive rise up to global climate change, you actually have this giant debate over, is the planet going to warm or cool? We're not sure because we don't know how the machine actually functions. And here, just to add some legitimacy to it, this book by Nigel Calder was actually a series by the BBC on the coming ice age. The book, The Far Right, The Genesis Strategy, is really interesting because that's written by Stephen Schneider, who some of you might know was a huge climate scientist, a huge advocate for global warming in the 90s and 2000s. Because, yeah, he realized as the models got more and more advanced, CO2 did eventually win out. But back when he first started, as a postdoc, he was a big advocate of global cooling because that's what the science was saying at the time. And the cooling effect, in the middle by Lalo Ponte, there's actually a scientist called Reed Bryson who, wow. I'm just not going to touch this or read the quote. There was a scientist called Reed Bryson who actually wrote the preface to the book. And Bryson's basic point was like, I can't even believe it was published in the preface, but the preface was saying, this guy's arguments are all over the place. We can't trust it. I think there could be a cooling, but I'm not as confident as this guy. We still don't know how this machine works. But I have part of the quote here that I could see. There's no agreement on whether the Earth is cooling. There is not unanimous agreement on whether it has cooled, or if one hemisphere is cooled, or if the other is warmed. One would think that there might be a consensus about what data there is, but there's not. There is no agreement on the causes of climatic change. This is 76. This is getting surprisingly recent, right? New York Times, 1974. I'm just going to go through some of the general media discourse to prove I'm not, insane. In the long term, climate is cooling off, or is it warming up? As for tomorrow's weather, even the world's biggest computer can't say for sure what it will be. The Globe and Mail, 1976. It does hit home. You start seeing this in Canadian newspapers, and you see the major change in climate predicted by the CIA. And down in the far right corner, it's the cooling trend. This is going to be the climate change. Back again, New York Times, 1979, could be warming. What's interesting, this is also sometimes the same author going back and forth because he's just going through what these scientists are talking about. This one was, this was the Toronto Star in 1980. This was a new one I'd never even heard before. It was climate warming could cause sea rise. The level of the sea rise will change the jet stream. That will cause a tremendous increase of snow. That will catalyze a new ice age. We're going to have global cooling. It sounds weird because it is. Just the point is that people were all over the place at this point in time, and this is what the public and the general media were kind of subjecting people to. And the final one, in terms of, there are a whole bunch of these, so I just took some of the fun ones. This was the Toronto Star in April 1981, and they're a small article, but it's warming is actually pretty good. It will turn, what is the quote? CO2 warming will turn Canada into a vast productive market garden, the United States a desert. But what then? So you see some nice Canadian, punches into the United States, as is wont to do. But the point is, how can the returning cold be stopped? The article is looking into the future, saying, how can we keep this warming up so that we can grow our vast market gardens for export to the rest of the world? So the public right now is aware that the global climate is a thing, but it's pretty confused. Is it warming? Is it cooling? How does it work? Something happens in 1978, and this is something I've long wanted to do in a presentation, and that's to include dinosaurs. What actually ended the dinosaurs? This was also a fairly recent discovery. It was in 1978 where this guy named Alvarez said, well, what if it's not a plague? What if it wasn't something biological? Or what if it wasn't the rise of a new species? It's like, what if a giant asteroid came and smoked the Earth so hard, it threw so much stuff up into the air, where what it caused is a giant climatic change, a giant shift in the global climate, the global cooling. Dinosaurs have no food, they freeze, they die off. And that was his theory in 1978. In 1971 it was published, and now that's pretty much what we know as the, I can't pronounce it, but the Chicxulub crater in the Yucatan Peninsula in Mexico. This theory is pretty much won out. So then, as this theory started gaining acceptance, you have other people that are looking at things like volcanoes and asteroid strikes. So you can see on the left, that's kind of an artist's visual representation of an asteroid strike. And on the right, that's actually a volcano exploding. I can't remember which one. The nature of this is that as an asteroid hits, or even as a volcano erupts, it is that global cooling effect they were debating in the 1970s. You throw a bunch of stuff up in the air, it blocks light, it blocks heat, and the global climate cools. So now, for example, if let's say that giant volcano blows in Bali, that will cause a slow pause in the steady rise of the Earth's temperature, because it's injected so many particulates into the atmosphere, it will cool the Earth. And just as an aside, this is one of the global kind of geoengineering schemes that people have developed as well, where they say, if we have crazy runaway climate change, let's fly up into the atmosphere and just dump particulates everywhere, and it will cool the Earth. But what's interesting is that what do these clouds also kind of look like?
Nukes.
Yeah, exactly. If I were to tell you that the one on the right was a nuclear blast, you'd probably say that's correct. So all of a sudden, in the 1980s, this public unsure of what the climate is, where it's going, how the hell it works, you have this concept developed that absolutely takes off. And it's nuclear winter. And so the idea of nuclear winter is, imagine the power of that asteroid hitting or the volcano going off, multiply that by 1,000 times. So what nuclear winter basically implies is that you would throw so much dust and soot and dirt and debris up into the air that it would actually get caught in certain levels of the stratosphere and be circulated over the Earth. And it would actually cause winter from nuclear weaponry. We don't have to go into the fun dynamics of how nukes work, but a nuke essentially takes a piece of the sun, brings it down to the Earth, and sets it off for a fraction of a second. So everything nearby instantly catches on fire, just goes up in flames, and then almost like a thunderclap, you have the wave hit it afterwards, and it kind of blows it all up into the atmosphere. It's really charming, nice stuff that people have forgotten about, I think, in a way, how horrible it actually is. Think of the intro to Terminator 2, right? Sarah Connor's dream, if anyone remembers that. I'm really dating myself right now. And they started modeling this. Ehrlich and Carl Sagan, Carl Sagan from Cosmos, he went under this massive political bent against, you could say, the American military-industrial complex, saying, this nuclear winter thing, you guys have been screwing this up for decades because all you were doing was focusing on the blast. Instead, if you actually focus on what else happens, if you focus on these global atmospheric dynamics, what happens to this soot, the nuclear winter is actually more horrible than what happens in the initial blast range, because instead of just killing all the people in the surrounding area, poisoning some people in a greater area through radioactive fallout, you actually have a danger to all of human civilization and life on the planet, because you block out the sun, no one can get food, essentially the whole planet will slowly start to starve. And this was taken very, very seriously. So the Reagan administration started doing inquiries into this, they agreed with its findings. We'll go into that. But the Bulletin catches it too. So instead of talking so much about global cooling in the 70s, the Bulletin was kind of silent. It was a media thing. Now the Bulletin is all over global cooling, but it's in the form of this nuclear winter. The 1983 issue in particular focuses almost entirely on the concept of nuclear winter. But what is it that's kind of snuck in there now is this idea of globality, this global object, the nuclear threat, and also climate. You see climate appearing in places. So now it's no longer that greenhouse effect that Suez and those people were talking about. Now it's climate. So the climate is now a global thing that's attached to this nuclear winter and this threat. And it was very popular. So instead of CO2 and particulates, you have cooling through nuclear fire. Some of these books, I don't know if you can see them in the local library. I know. The gems are in the oldest books you can find sometimes because they have the coolest insights and the biggest questions to ask. Like, how did we get here? Just one more example. This was Carl Sagan's article in Foreign Affairs back in 1983. And now it's just in the titles of articles. It's just leaping out. Nuclear war and climatic catastrophe, some policy implications. And of course, he's citing the Bulletin of the Atomic Scientists from 1947, using all of these kinds of discourses of existential fear that we're familiar with today and that started back in 45. It's not even possible to imagine the effects of atomic war. It will endanger the survival of man. Except now it's not just nukes and atomic war, now it's climate. They're both, again, becoming more and more intertwined. And this was big enough, and I recommend everyone to watch this because it is super cool. 1983 ABC News Viewpoint. Has anyone seen this? Watch it on YouTube, and it's Ted Koppel, Secretary of State George Shultz for Reagan, Kissinger, McNamara, Brent Scowcroft, Carl Sagan, Eli Wiesel. It's just like a superstar debate talking all about nuclear winter, because there have been so many movies and so much panic amongst people at that point about what this global climatic freezing will do, that the actual acting Secretary of State, George Shultz, had to go on TV and talk to Ted Koppel about this debate. And it's fascinating, obviously not just because there's such influential names in the history of international politics, but also to compare the style of media discourse and the respect for all the panelists that they have for one another at this time, despite their differing positions. You know, Kissinger versus Carl Sagan, they still respected one another. And then you turn on TV today, and that's an entirely different genealogy to do. But the point is, this was massive enough where the US House, the Senate, Department of Defense, they all launched inquiries into global climatic change through nuclear winter, its possible destruction of civilization. So it was actually at this moment that popular consciousness and popular culture started talking about global climatic change. But it wasn't the warming we're familiar with, it was actually climatic change through nuclear winter, embodying all those kind of existential anxieties that had been developing for so long. So it's brought into being now as an everyday and public object. People know what this global thing is. It's no longer regional and sovereign. It's an existential threat, as it's always been. It's determined by states, so states have control over whether or not this is going to happen, and it's a cooling. But what's interesting now is that the climate isn't just this neutral or objective object. People aren't deciding whether or not it's good or it's bad. People are actually talking about the climate, this cooling object, as a threat. So I took one example from Carl Sagan's book, one of the ones that was just featured. Nuclear winter enhances self-deterrence by increasing the ultimate risk to the aggressor through the likelihood of retaliation, not by the adversary, but by the Earth's climate system. So the Earth's climate itself has now become the adversary that states and people alike have to fight against. And again, for the majority of the public who weren't people like Suess or Ravel that were studying this thing, this was their first introduction to what this thing above us actually was. Yeah, it's an existential threat that we have to deal with. In 1988, this was, if anyone here studies environmental politics, but a big precursor to the Intergovernmental Panel on Climate Change was the 1988 Toronto Conference. And I was like, yay, Toronto, we're in there. This was the opening statement. So you have humanity is conducting an unintended, uncontrolled, globally pervasive experiment whose ultimate consequences could be second only to a global nuclear war. And scroll down, it's a major threat to international security, and it's already having harmful consequences over many parts of the globe. Now, what's interesting is that, again, that Ravel and Suess paper from '57, that's the paper that has that famous line, humankind is now conducting an uncontrolled experiment that will never be able to be replicated again. And you see that echoed over and over again all over the place, and you'll still see it today. It's in the latest IPCC report. It's such a powerful line. And here you see it. They've taken the Ravel and Suess quote, but they've tossed in, again, second only to a global nuclear war. Because at that point in time, any climatic shift already tied into these discourses of nuclear winter and that scary sense of existential abyss. And again, you see this kind of paper throughout UN documents at the time. So this is one from 1989, the Department for Disarmament Affairs, study on the climatic and other global effects of nuclear war. It was common sense. If you have a climatic threat, it's going to be nuclear. You tie two and two together. But in the late 1980s, you also see, again, tremendous advances in computer technology. I don't know if it's Murphy's Law or whatever. Is it?
Moore's Law.
Moore's Law. Sorry, that's the one. Some type of law. There are many. You do finally see CO2 win out over particulates in the global warming debate. So no one's talking about global cooling anymore. What's odd is that people slowly stop talking about nuclear winter, even though the threat is still there, and it's there today, right? You don't hear too many people talking about nuclear winter when they're talking about nuclear exchanges between Russia and the United States or whatever. But the threat hasn't gone away. But instead now they start realizing, yes, this tremendous production of CO2 was correct. That paper back in the 50s that no one really paid attention to, and Arrhenius's predictions back in 1896 that he wrote, didn't really care about, and everyone else ignored after. The tremendous computing power that's available now is actually able to use a general circulation model to say, yes, we can now not just mirror how the climate works today, we can predict in the future that this will cause a discernible climatic change. And not through winter, but through cooling. So in the Bulletin in 1992, and this will probably be the last kind of Bulletin mention, Spencer Weert, he's a historian of kind of climatology, and the natural sciences. He writes an article, Out of the Nuclear Frying Pan and Into the Fire. We're finally, for some reason, we're getting away from the nuclear winter threat, but we're moving into climate change, which is odd because it's not really true. Both threats are, they're both there, but he's implying they're completely separate. We're away from one threat, and now we're into this other one. And now we're into this global fire, we're into global warming. So there's no more focus on nuclear winter. In the old terms they used to describe greenhouse effect, kind of greenhouse warming, that's gone. Now it's just climate change. No more global cooling. Climate change means fire. Climate change means global warming. And this is exactly the conceptual kind of parameters or the way we think about climate change that's adopted into everything that we hear is foundational for the global climate regime today. So the formation of the IPCC in 1990 and every report since then, all the reports that we look at when we look for some indication of what's happening with the global climate, it was that particular concept and those particular technologies that went into forming what that was. And the catch with the IPCC is that it's not like, and a lot of people have problems with this, there's not a variety of different cultural contexts about what climate is, there's not a variety of different religious perspectives or cosmologies from, let's say, indigenous peoples from around the world. No, if you want to be part of the IPCC, you have to play by their rules. You have to follow exactly what their type of science is, you have to follow exactly what their models are, you have to share a similar conceptual boundary of what the global climate actually is as an object. So guys like Mike Hume writes how this is actually a form of planetary management. It's forming a global knowledge where you can only join the club if you think like we do. Now, it doesn't mean that climate change isn't real or that it's a biased thing. It does not mean that at all. What it means is that there's a particular hegemonic type of knowledge that came out of all of these discourses developing at this point in time. And it was that specific form of knowledge that became stamped as the gold standard. And that's what kind of goes into everyone's head today as they think, what is the global climate? How does it work? You think about this. Essentially, you think about a concept that comes out of a computer, out of a general circulation model. And there's an excellent book on that by... It'll come to me. There are a few books on it. But coming towards the end, this was that concept that we have today. So the global climate as we know it, when did this changing climate actually become global? It was actually in the mid to late 80s through the formation of such institutions as the IPCC that actually linked up and said, okay, Russia, China, Sweden, the UK, you all are trying to calculate one particular type of climate, of what it is and how it works. It was in the 80s, they all linked up in the IPCC and said we all have to share the exact type of modeling and the similar sets of equations. Otherwise, we're not going to be able to work together. We'll be speaking different languages. So it's actually in the mid-1980s when the global climate became an actual thing and was brought into regimes of governance. Foundation was not in climate science. It was actually in nuclear fluid and thermodynamics. Again, you trace it back to Rick Meyer's textbook. And the workings of those GCMs, fundamentally the same today. The first carbon that was traced was not actually CO2, it was radioactive. The climate was brought into being through the circulation, tracing atomic weaponry. GCMs and the mathematization of nature. So in order to actually figure out how this thing works and what it is, you don't reach out and touch it, you actually have to quantify nature. Put it into the machine, see what it spits out. And that was the shared methodology that all these groups adopted. Game theory, as odd as it sounds, is always lingering in the background because it was always part of that initial structural inclusion and how a lot of these computers worked and how they thought. Just to take an example from an aside, if anyone who researches the Anthropocene and Earth system sciences and the planetary boundaries model and those kinds of things, they're extensions of these climate models. And they say, well, we're going to include humans and social behavior into our models, but how do they do it? Just the way the models have been designed, the only way they can include humans and social systems into their models is by making every human a rational actor and essentially submitting all societies and peoples to game theoretic assumptions. And I always find this interesting because as critical IR scholars were always into thinking differently, and I know a lot of good friends that have adopted the planetary boundaries model and Earth system sciences as this kind of this mode of thought that will challenge dominant types of thinking. And I agree in many ways it does. But foundationally, when you get down to the conceptual representation of people in those, everyone's the rational economic man. It still boils down to game theory. Particulates and cooling did play a role. Global nuclear winter, that's when the global came in. Existential annihilation has always been there. As odd as it sounds, it's just when did it get attached to CO2? When did it kind of shift around? And Joseph Masco has also written on this, on the state militaristic component of this, which I think anyone could read and be just blown away by it, whether you're interested in climate change or not. But it boils down to, I can't summarize Masco in a few sentences, but geophysics in the state is obviously very tied to boundaries and kind of that protecting the homeland, so to speak. They're tied more into the nuclear militarism we're familiar with. So by definition, you're going to have a concept that's, let's say, biology is very about integration, about overlaps, about interconnections. It's the opposite of borders. Same with things like climate change or global environmental problems. By definition, anything like climate change or global environmental change is antithetical to the state, because you're not going to be able to maintain those borders, and it also goes against the kind of economic, industrial, socio-political ways that states sustain themselves. So that also ties very much into this as well. So whenever we're thinking global climate change today, in the background, it is still tied into that inherent, what can the state do? It seems like the state is the only thing there. Again, I want to stress this does not mean climate change isn't real, which is, sometimes I'm asked that. You're questioning the natural history. It's like, well, yeah, it doesn't mean it's, the science right now is incredible. We've never had this many people working globally on one problem and coming to this amount of agreement ever. Like, it's unprecedented how strong a lot of the science is. But obviously it's not perfect. It's a definition of science. It comes up with evidence. It doesn't come up with pure truth. It's also the nature of history. We take things that we think are immutable, we chase down different ways they are, they could have been. It allows us to think differently about things we once took for granted. Our thoughts have a history. So even this idea of global climate, when you hear about global climate change in the news, that's not this permanent idea of what the global climate is and was and always has been. It's actually a really recent idea that we've all kind of adopted and taken in. It's only come up within the past few decades. So again, conclusions, if I had to make a few, the New World Order that Falk talked about, that shift in consciousness, that form of conduct that Lippmann mentioned that had to kind of get inside everyone's head. One thing I'm thinking about looking at is whether or not this concept of global climate change that we all share is that particular form of order. It's whether you're in Canada, the United States, or in China, or wherever. If you're going to the IPCC and you're trying to play ball, or even if you're arguing with your friends, you're still sharing the same fundamental notion of what this object is, what it does, how it can change. That alone is a particular kind of conceptual mode of shaping knowledge and conduct. I won't go through that much. Climate change, instead of being from the nuclear kind of catastrophe into global warming, they can't really be separated as clearly as we want. So in some ways, when we think about climate change, in the very back of our minds, we're channeling these previous discourses of nuclear war. So in that article by Weird in 1992, he says, yeah, it's a shame that climate science wasn't allocated the same amount of money as nuclear weapons research, because then we would have discovered all this stuff so much earlier. We'd be so much better off. And what I found, looking through the Bulletin and these other sources, is, well, no, that's a presentist assumption, right? That these different objects. It turns out our knowledge of climate change today came from nuclear war and those atmospheric sciences. So if that money hadn't have been invested, if those chips hadn't fallen in that particular way, we may have a completely different understanding of climate change, or something that's a bit, maybe it would take it into consideration different regional climates or different indigenous perceptions or different cosmologies, ways of relating to the world. I'm not sure, but the point is that they're overlapping epistemologically and ontologically. Existential annihilation has also moved from fear of the bomb to the global climate itself. That tinge of fear that everyone feels when they think about it. And where does that leave us for international relations? This is something that I'm happy to discuss. I'm not sure. And if you watch that debate from Viewpoint of 1983, it's humbling because they go around at the end and they say, how do we solve this nuclear crisis? How do we solve deterrence? And it's the only time they go around the table and everyone's like, I don't know, I've got nothing. I have no idea how to get us out of this. So where does that leave us, right? For now, we're supposed to come up with solutions. I think it definitely changes our representation of agency, what we as humans can do, right? We couldn't do anything about global nuclear war, and there's a certain lack of agency in terms of climate. Well, I can't do anything, I'm so small. So I don't know whether or not that's pulled over as well. And you have these certain security discourses that kick in as well, right? How do you secure yourself against a global environmental threat? Something that Masco ties into. And if anything, I hope this helps people think a little bit differently about the conceptual boundaries that structure our everyday modes of thinking. So even something like the global climate we think is natural, it's immutable, scientists have come up with it. Problem solved, that's what it is. Well, no, those concepts have a history. The things that go into our head have a history. They've taken particular twists and turns in really contingent, unpredictable ways. So our notion of globality, what constitutes the globe as a thing, what ties it together, our concepts of annihilation. Scary, but we have to think about it now with everything that's going on in the news. When you hear Kim Jong-un and the North Korean crisis in one page and you look over at climate change on the other, there might be much more of a conversation between the two and the histories and ways they overlap than we might think. And also agency, what people can do to make a change in this. I'm still figuring out how to reintroduce more agency into the global climate crisis. We all know clearly stop using carbon, easier said than done, but it's that sense of helplessness, or as I called before, it's a rationality of powerlessness. We just feel powerlessness. Well, it's not universal, that came in at a particular point in time and in a particular way. And before I finish up, echoes of the Anthropocene. If anyone studies the Anthropocene, I've done a lot of writing on that. But what's interesting is that the Anthropocene was thought of by this guy, Paul J. Crutzen, and also this other person, Eugene Stormer, who Stormer got out of the Anthropocene game after their first article in 2000. Paul J. Crutzen became his champion of the Anthropocene epoch. So that's what he's famous for right now. But what did he really come up? It turns out Paul J. Crutzen wrote the foundational article introducing global nuclear winter into academic and public discourse in the early 1980s. So not only did Crutzen come up with the Anthropocene, he came up with nuclear winter. He's a big, heavy hitter in terms of thinking. So maybe his massive contribution to the natural and social sciences isn't just the Anthropocene, it's actually introducing one of these germs of global climate change that we all take for granted right now. So he also, it illustrates there's a lot of entanglements between the Anthropocene, climate change, and these nuclear fears and anxieties that I think they've yet to be explored. So I'm going to wrap it up there. I've talked for an hour and 2 minutes, so if anyone has any questions, I'm happy to answer them. I'm still developing these thoughts, and I hope to turn it into a paper sometime soon. And it was a pleasure to come back here and talk to you guys. I know it's late, it's dark outside, and I appreciate you all giving me your time. So, thank you.